Hi guys, Shouvik here. Welcome back to your YouTube channel. So today we will solve another question from Leetcode itself. So let's get started. Yeah, so today we have this minimum equal sum of two arrays after replacing 0. Yeah, first we will go to the problem statement first. So in this problem they have given two arrays nums1 and nums2 consisting of positive integers. Right? They have given two arrays nums1 and nums2 consisting of positive integers. You have to replace all the zeros in both the arrays with strictly positive integers such that the sum of the elements of both the arrays are equal. Very straightforward, very simple. So what they are looking for, they are basically looking for there are some zero on the initial array they have given to us. So we have to replace the zeros. We have to replace the zeros of both the arrays with strictly positive integers such that the sum of the elements of both the arrays becomes equal, right? Now return the minimum sum you can obtain or -1 if it is impossible. Yes, I think the problem is very straightforward. So on both the arrays there are some set of zeros. So we have to replace all the zeros with some positive integers that we don't know, and finally we make both the array sums nums1 and nums2 is equal. We have to make both nums1 and nums2 is equal. And what is the minimum sum we can achieve thus? What is the minimum sum we can achieve thus that we have to return? Or if it is not altogether possible to make it -1, to make it equal, then we can return -1. Yes. That's it on the problem statement. So if we can go to some example test cases. So on this example test cases, you can see that is the nums1, that is the nums2. We can replace zeros in the following way. Replace the two zeros nums1 with values 2 and 4. So that is the resulting array, and replace the 0 in the nums2 with value 1. The resulting array is of the nums2 is become this. So both the arrays have equal sum 12, and that is the minimum sum you can achieve. So it can be shown that it is the minimum sum we can obtain. On this example test case, you can see 2020 they have given nums2 is 1 4. It is impossible to make make the sum of both the arrays is equal. To make both the sums of the array is equal, and the constant is in the range of 10 raised to the power 5. So you definitely have to think kind of like n log n or big O of n kind of complexity, right? Yeah. So now we can go to the intuitions building part. So there is a very straightforward observations if you are get it on the very first go. Like I am able to like get it on the very first go itself. So I am just giving you how actually the eagle eye you have to put to solve such kind of intuitions related problems. So it's working right. Let's move to this. Yeah, I can select yes. So if I consider, so let's suppose this is my nums1, and I have a nums2, and let's consider this is my nums2 and this is my nums1, right? So there are some zeros. Let's suppose on this array is this, and on this array let's suppose these are zeros. So I'm very greedy. So what is the first things I am looking for? So I have to make the sum of nums1 and sum of nums2 is equal. Both should be equal, right? Both should be equal. So that is the first conditions. And what is the second conditions? All the zeros should be replaced with some positive numbers. It can be greater than equals to 1. It should be greater than equals to 1. Like I can replace it with 1 or some higher value. So that is the second conditions. And what is the third conditions? The sum that we are looking for, the sum equal. What is the equal sum we are able to build? It should be minimum. It should be as minimum as possible. Equal sum, right? These are the major three conditions. Now, if I can tackle this equal sum, sorry, not equal sum, like this. Like I am trying to make the sum of every nums1 and nums2 as minimum as possible by using this. So by following the second principle, we are not allowed to violate that principle. We definitely have to replace all the zeros with 1, right? We definitely have to do so. And we have to make the sum is as minimum as possible, right? As minimum as possible. So to make sum as minimum as possible and replace all the zeros with some positive numbers, what is the very first things is coming to our brain? Replace all the zeros. We have to make the sum is as minimum, and we also have to replace the zeros. So replace zeros with 1 only, because 1 is the smallest among the positive numbers. Like this way, then I am followed these principles. I have done with the principles 2, and I have followed this principle 3 also. Principle 2 and principle 3 is followed. So these operations I will do on both the arrays. So whatever the values on, let's suppose this is x, y, z, this is a, b, c, whatever the values, positive values they have at, we will not alter them at all, but we'll replace all the zeros where we found the zeros with one, with a positive one, with a positive ones for both the arrays, so that we have already followed our principles 2. We have to replace all the zeros with some positive values, and we also followed the principles 3, that we have to make the sum as minimum as possible, So after doing that, let's suppose our left sum becomes x and our right sum becomes y. Let's suppose this is. So now the conditions 1, 2 and 3 already satisfied. We have replaced all the zeros on both the arrays, and we have tried to make the sum as minimum as possible, So now what is the first principle? We have to make x equals to y. We have to make x equals to y. Definitely we have to make. So there are conditions then. Now if let's suppose our x is greater than y, so my left sum is bigger. Right? So what is the extra I have to put to make my right sum equals to left sum? We don't have the liberty to decrease anything, right? So that whatever the values of x and y, all are as minimum as possible. We have the liberty to increase it further. We also have the liberty to increase it further. If there are zeros altogether we have encountered, then rather than replacing these zeros with 1, we can replace to some more powerful positive integers, right? So that they can equivalent. So if x greater than y, if my left sum is bigger, so I have to increase my right sum. I have to increase the right sum. So maybe I have replaced the zeros with 1 only. So I definitely need to replace that zeros with with 1 only, with some, not 1, more than some bigger number. Yes, if I can do, then I am definitely able to fill the gap x minus y. So that is the extra in x, right? Extra in left sum. So I have to fill the extras by replacing some zeros on the right with some more powerful numbers. So if I have at least a single zero in the right array, then my job is done. Do you feel my job is done? Yes. Rather than replacing with 0, rather than replacing it 1, I will replace it with y minus x. What is the delta we have? So what is then I am looking for? If my x greater than y, or more specifically I can write my left sum is greater than my right sum. If that is the case, then what is the extra I am looking for? I just need a 0 on my right side. Then I can replace with any of positive numbers, so that I can fill this gap. Then my job is done. So if that is the case, and if I have some 0 present, 0 in right, let's suppose 0 in right, that is a booleans I can take, right? 0 in right. So if that is so, then yes, I am able to satisfy both. And what is the minimum sum? The left sum, because I will be then try my right to make it as equivalent to left. And else, tell me, that is the -1 case, right guys? That is the -1 case. So -1 means my left sum is already higher, and I need some zeros in the right sum to replace them with some more powerful numbers, so that I can achieve my left sum. We build both our left sum and right sum as minimum as possible, until my left sum is bigger. So I need at least some zeros, at least 1 zeros to my right segment, right array or nums2, so that I can replace with some positive numbers. But I don't have. So return -1. Tell me guys, the reverse case, elif case. So that is my left sum is greater than my right sum. On elif, my left sum is smaller than my right sum. Tell me, what is the what we definitely have to look for? If there are 0 in left, so we definitely need some zeros in the left, so that we can fill the gap. That we just discussed on the reverse case. If that is so, then what we have to return? Return right sum, because we are always trying to make both of our left sum and right sum is as minimum as possible in the initial go. Same guys. If you understand one segment, the like writing it for the of the reverse case is just you have to change the variables to the reverse. And what is the else? If we don't have, then return -1. And what is the else case? So first if is for if my left sum is greater than right sum. Second if is for left sum is smaller than my right sum. And else if none of the cases satisfies, so that means my left sum is equal to right sum. So do I have to do anything? No. Just return any of them. Just return maybe left sum. Return left sum. As simple as that. Yes guys, so that is the problem. That you have to just do. So that is the pseudocode. Now we can go to the code iterations part. So I have taken 4 variables, one like left mean sum, right mean sum, left 0 present, right 0 present. So as we discussed, we definitely need to just know if there are 0 present to my left or 0 present to my right to check the conditions, if elif wala conditions. We definitely have to create these variables. Now we have just standard 2 iterations to my nums1. What I will do, if each it is 0, then I am increase to left mean sum to +1. I am consider it to 1 only, because I have to make all of them as minimum as possible. And also you have to replace with some positive number. So we are doing so, we're replacing with +1. And I am marking that yes, we just saw a present in the 0 in my left subsegment or nums1. So I am making left 0 present to be true, left 0 present to be true. And else if that is already positive numbers, then we can add to my left mean sum. Same things I do, same things I have did here for my right segment, for my nums2. Each 0, right sum plus equals to 1, right 0 present true, right sum plus equals to each. Now exact the same conditions that we just discussed in our one. If my left mean sum is greater than my right mean sum, if right side holding sum 0, then return left mean sum, else return -1. Just reverse case, if left mean sum is smaller than my right mean sum, then if 0 present in my left 0 present, if my nums1 holding sum 0, okay, it's holding, man, then return right mean sum, because that is the minimums you can achieve for both the arrays to be equal, else return -1. On else case, both are already equal, return any of them, return left mean sum or return right mean sum, any fine. Yes guys, so the problem is as simple as that. Now if we can discuss quickly the time complexity of this particular problem. Yes, so you can see, right, how you can like basically approach to a particular problems, how you can build your intuitions to a particular problems. On that part it is going to be quite on the easy part, but if you can on the initial go making the things in over complicated, then obviously you are not going to reach on the optimal solutions in the very first on the very first go very quicker. So that's the reasons for every video I am trying to make your intuitions building capability to be on the different levels, because then only on in any interview you can tackle any problems all over the world. You can just solve it like this way you can solve it, right? So that's why I am just focusing on one note explanations, how you can make your intuitions on different levels of the other candidates. Yes guys, so now we can quickly discuss the time complexity. Tell me guys, the time complexity. I think you guys should be definitely predict the time complexity. We are just iterating one for my nums1 and one for loop for my nums2. That's it. Others are we are just playing with if else conditional statement we have just written. So the time complexity is definitely big of n plus m. And what is the space complexity, guys? Tell me. The space complexity is, do we use any space altogether? All are variables, right? Left means sum, right means sum, left 0 present, right 0 present. All are variables. We are playing out entire games with variables only. So on space part, it is big of 1. It is a constant space, and that is the most optimal solutions that you can achieve for this particular video. And I'm definitely sure that is the most optimal solutions, because you and at any worst case you just have to iterate both the arrays to build your answer. So that is bound to be the most optimal solutions for this particular video. Yes guys, so if you are able to understand till this point, I guess you guys are already doing so. Please do subscribe to our channel, and please share the videos to our friend circle who are also preparing for top product based company and brushing up their DSS skills. And please turn on the notification so that when we are going to live to our next video, you will get the notification as soon as possible. So that's it guys, that's it for today. Let's meet tomorrow with another beautiful question. Bye guys, bye.